Hello, our students, A2 students, A-level students, international advanced level for Edexcel board. Today we have a recording for important ideas in a past paper questions for June 2023 for your external exam unit 4. There are some important notes about the paper. First of all, there is a copy of the periodic table, as you know. And if you have like start questions, you shall remember that the combined sentences was needed, and you shall answer the combined sentences very well. Make sure that you can read each question perfectly, in a perfect way, and you can solve the question. The first multiple choice question is, we have a homogeneous equilibrium is shown, which is W plus X. It's an equilibrium with 2Y plus Z. What is the Kc expression for this equilibrium? As you can see there, since the equilibrium express the products over the reactants, so we have 2Y and Z. So Y is squared and multiplied by the Z concentration over the W concentration and X. So the choice B is the correct one. For next question, because the Kc is written like that according to the products and the reactants. For the next question, the reaction shown occurs at 360 degrees. This is very important because for this degree, you will find, or you will see how much or what is the state of each substance. So in this case, all they are gases. So you will see that we have a homogeneous mixture, not heterogeneous one. And because it's an exothermic reaction, so increasing the temperature will shift the equilibrium to the left. So the correct answer for this choice is it's homogeneous and the product Kc, because the product's concentration decreases as we shift by increasing the temperature. So it is homogeneous and decreases. Now, for question 3, what are the units of Kp for the equilibrium shown? You know the Kp can be written like that. So Kp is, what's the Kp is? Kp equals the P squared of NH3 over the P of N2 times the P to the power 3 of H2 gas. And you will see that the unit, if you apply that, the unit is ATM squared over ATM multiplied by ATM to the power 3. So what we have ATM to the power -2, the overall. So C is the correct answer. Now, for next question, high performance liquid chromatography, HPLC, is used to separate a mixture into its 3 components. The resulting chromatogram is shown, and you will see there he gave you the retention time on the x-axis, and what we have is the absorbance. So he's asking you which is correct for the labels on the axis. First, it is the time on the x-axis, and as you know, the y-axis will give you the absorbance. So D is the correct answer. Because all the other choices, absorption, it will not be on the x-axis, and time, it will not on the y-axis, or if value these are used for the chromatography. So the most possible answer to be correct is D. Now, for next one, for next question, question 4 part B, which is the correct for the components E, F, and G. Here he's asking you the most attracted to the stationary phase. The most attracted to the stationary phase is that one which is more bonded to the stationary phase, and this will tell you that it is with a larger retention time. And which one is the most abundant? That one which gives us the highest peak. So it will be F. If you return back, you will see that G is the most one that's attracted. This is the most attracted to the stationary, most attracted. Again, from where we know that, from its highest retention time. And you will see that frequency, or that peak with the higher absorbance, is F. So the answer will be G and F for the next part. So the most attracted one is G, and the most abundant is F. So D is the correct answer. Now, for the coming question, we are talking which pair of compounds can form racemic mixture. Racemic mixtures means that we have two enantiomers according to the optical chiral center. So you will see there in the first one, the groups which they surround the chiral center are different. For example, they are not the same. So for part A, it is not racemic mixture. For part B, you will see that they are the same structures. So they draw the same molecule for both choices. And for part C, you will see that we have look, OH, CH3, CH3, so the same groups, but they are, okay, here you will see which one. You can see that they are CH2, CH3. These are different groups also. There is a difference between this group and this group. So the correct answer is two enantiomers which they present in D. They are not superimposable over each other, so we have a racemic mixture. That's the correct answer. Now, for next question, okay, metoprolol is a drug used to treat the heart problems. The structure of metoprolol is shown. Don't worry about these strange names in the external exam. So at the end it is component of alcoholic group, or it indicates that we have an alcoholic group in the structure. He's asking you how many chiral centers are there in the molecule. He did the skeletal formula. He drew the skeletal formula. So you shall count how many chiral centers with 4 different groups for each carbon, or the carbon with the 4 different substituents. It will be a chiral center. For this carbon, it will not work. The methyl groups, they not considered because we have 3 H's there. And here we have 2 methyl groups, so it will not work. Here it's not a chiral center. Here we have 2 hydrogens. There we can consider it as a chiral center because we have 1, 2, and hydrogen atom, you see. So it is a chiral center. So this one is chiral. Now it's 1 chiral center. For this, it will not be a chiral. Oxygen will not. In the ring, there is no any chiral center. Also, there is no chiral there, no chiral, no chiral. So only we have 1 chiral center, which is this carbon, because it is attached with 4 different substituents or functional group or groups around it. So the correct answer is B, which is 1. Now, the next question is question 7. Yes, the decomposition of hydrogen peroxide is catalyzed by the iodide ion. As you can see in this equation, the hydrogen peroxide decomposed by the aid of iodide catalyst, and there are 2 reactions. The first one is fast and the second one is slow, but take care, the IO is an intermediate there, IO minus, so it is not included in the rate equation. What we have, if you add these 2 equations, and here the order of hydrogen peroxide shall be to the second order, and it depends on the I. So if we add the equations, so the equation which includes the hydrogen peroxide and iodide as a catalyst, since IO is an intermediate, so both C and D are incorrect answers. And for the second one, because it is not second order for hydrogen peroxide, but the first equation shows that the hydrogen peroxide is second order, so A is the correct answer. Okay, now the next question. Sorry. The next question is, okay. The next question is this one. Okay. Imagine if you have these 2 carboxyl group and 2 alcohol, so it is composed by the reaction of these 2 monomers. It's what's known as the ester group. If you flip the molecules, if you rotate them, you will find the correct answer will be what? The first one, A, but let us see the other ones, so you can see they are not the case, because here the CO group stays, and incorrect combination, so the correct combination for the 2 molecules is A. Just you shall try the combination, just rotate the molecules and you will see that the correct answer is A. Now, For the next question, he's asking you a partial mechanism of the reaction between ethanol chloride and concentrated aqueous ammonia is shown. And then the curly arrows are escaped from the diagram. They are not included, and he is asking you how many curly arrows are needed to complete the mechanism. You will see that here we have the first arrow. Look there. This is the first arrow. It comes from the nucleophile to the partial positive carbon. Then there is an arrow there to create the negative charge on oxygen. Then these two electrons was returned back. Here we have 3 arrows. And this leads to the formation of this intermediate. Now, another ammonia molecule will attract the hydrogen, and hydrogen will return the 2 electrons to the positive nitrogen central. And what's else? We have there the arrow, as you can see, to lose the chloride. Now, if you count the arrows, you will find that we have, look, 1, 2, 3, 4, okay, 5, 6 arrows was needed to describe the reaction. So that's why we have, or that's why the answer is 6 arrows was needed for the reaction. Okay. Now, the next idea, what is the IUPAC name for the organic product? Where is the organic product? We shall name this. As you can see, it's an amide. So here we have 1, 2, so it will be ethane or ethanamide. So the correct name for this structure is ethanamide, which is the B choice. It is B. Okay, now for the next question, here, how do the boiling temperature and the solubility of water in water of butanoic acid compare with the values of hexane? Okay, how do the boiling temperature and the solubility of both differ? For the boiling temperature of the butanoic acid compared to the hexane, it will be higher. And also, since we have a polar and hydrogen bonding for butanoic acid and water, so the solubility and the boiling temperature of an acid, the butanoic acid, compared to the hexane is higher. Now, for this structure, which acid would be produced by the hydrolysis of molecule shown? Now, here we have 1 carbon. This one is hydrolyzed. 2, 3, and you will see this is number 4 in the longest chain. and you will see the carboxylic acid. So this acid, or the hydrolysis of the carbonyl group, it is changed to the acid, as you can see. So it will be, which one? It is 3-hydroxy 2-methylbutanoic acid, since the acid which is formed is this one, and then we have 2 carbon, and then methyl group, and then here we have the hydroxy group. That's the acid which is formed, and when you count from this 1, 2, 3, and 4, and you will see that's the longest chain for the structure. So it's 2-methylbutanoic acid and 3-hydroxy. So this is the correct answer. Now, what we have there, which is produced after the polyester shown is hydrolyzed with excess sodium hydroxide. Okay, if you hydrolyze that with sodium hydroxide, what's broken there is this one. What is broken? It's this bond, as you can see, this one which is broken, and it will form HOCCOH bond. So we are talking about the diol, ethane diol, 1,2-diol, and what's produced also is the following structure, which is C double bond O, O negative, Na positive, and the same thing from the other side. So it's negative and positive. Clear? So as you can see, one important product, or one of the important products in this reaction, or what is mentioned in the choices of the question, benzene 1,4-dicarboxylic acid, is wrong, because it's the acid, it's the salt of the acid which is produced, and this one, it's 1,2-diol. So that's correct answer. And sodium ethane diowate is not, and water is not 1. So what's produced there is the diol and the salt of the carboxylic acid. Now, here for question 13, for question 13, you will see that the titration curve shown is produced when the base is added to an acid. Okay, as you can see, the pH started from 3 and it's finished to around 12. And which indicators could be used for this titration? Now, if you return back to the data booklet, you will see what's the demanded vertical line is this one. Okay, so it is started from around 5.8 to around 10.2. So between this range it is, you can return back to the data booklet, and you will see that the correct answer is the bromothymol red, the bromothymol blue, phenol red, and phenolphthalein as correct choices. Okay, so we have the bromothymol, phenol red, and phenolphthalein. So the correct answer is B. Which acid and base could produce this curve? As you can see, there is a strong acid and weak base, and what is correct there is choice A, not the others, because the pH started from around 3 and the midpoint comes around 8.5 to 9, which is in the basic form. This means that it is a strong base with weak acid. That's why A is the correct answer. Now, for the next question, okay, what we have a diacid, and he is asking you which could be the titration curve with the sodium hydroxide. Since it's a diprotic acid, there are two pH middle point. It is not basic titrated with the acid, so B is wrong. C is wrong because only we have middle point. Here we have 3 points, and that's why the correct answer for the titration curve is A, because it's a diprotic acid and we have 2 points of titration. So A is the correct answer. For the next question, he's asked you to name it. Since we have 2 priority or 2 prior on the above side, and we have 4 carbons, so it is Z-butene dioic acid. That's the correct answer. It's just naming. And for the last 2 questions, which one of these is not conjugate acid? As you can see, those are not donating only 1 proton. All the others, they donate 1 proton only. And for the last one, you can calculate the pH for the question. Here he gave you the number, the mass number, okay? Because he gave you the mass, you can find the moles by dividing over the molar mass. Then you will use Kw equals H plus concentration times OH plus concentration, but because it's barium hydroxide, we have 2 OHs. So the concentration that you find by dividing this over this, you find the number of moles over 200 cubic centimeter or 0.2. You find the OH concentration by multiplying the concentration of the base times 2. Then use this number and find the H concentration. You will find that the pH is 13.1. Good luck in this paper. That's the multiple choice section. For the coming videos, we will do the short answers, the questions, or section B and C for this papers. Thank you for good listening.